Hey guys, as you are sitting in class, I just arrived in Scotland today. I should be in Edinburgh. I've probably been there for a couple hours, but of course I wanted you to do your math, and so I pre-taught the lesson for you. So today we are doing lesson 2.1. It's properties and operations. You guys are going to like this lesson because it's actually pretty easy to do. We're only going to work with two of the operations, really. We're looking at addition and we're looking at multiplication. And the reason why we're looking at those two is because they are related operations. And there's really three properties that we're looking at. And when we use the word property in math, it means law. So no matter what we do, as long as we follow this property, then it's the law of math and your answers will always be correct. So the first property I want to talk about is the commutative property of addition. Now the word commute means to move. And so when we're talking about the commutative property, it's something that you guys have done your whole life. You know that 2 plus 3 is equal to the same thing as 3 plus 2. So it doesn't matter the order that I add things, their answer is always going to be the same. So what we know, 2 plus 3 equals 5, and we also know 3 plus 2 equals 5. So we can commute the numbers, and the answer will be the same. Now, the tie-in with multiplication is the same concept. So if we're doing the commutative property of multiplication, it means the order that I multiply numbers in doesn't change the answer. So I can multiply 5 times 2 or 2 times 5. The answer is always going to be the same. Now, why does that help us? Well, sometimes we want to rearrange numbers when we're actually adding or multiplying. Sometimes the order that the numbers were given, it doesn't make as much sense for us. So as long as we know we can move those numbers to make it easier to do mental math, then we go ahead and do that, and then we can solve our problem easier. The second property I want to look at is called the associative property of addition and the associative property of multiplication. And again, they're basically the same thing, it's just one is with addition and one is with multiplication. Now, the way that you can remember the associative property is it has to have at least 3 numbers. So if I have 2 plus 3 plus 4, notice there's always addition. I'm only using plus signs. I'm not doing order of operations. The other thing with the associative property is we use the grouping symbol of parentheses to say what we want to do first. So if I solve 2 plus 3 plus 4 and I do 2 plus 3 first, that's 5 plus 4, which is 9. However, if I keep the order of the numbers the same, so notice I did not change the order of the numbers, but I go ahead and move those parentheses. So now I have to do 3 plus 4, which is 7, plus 2. Notice the answer is the same. So that associative property means I can regroup numbers to make it easier to solve, mentally especially, and I'm still going to get the same answer regardless of what I do. The same rule applies with multiplication. So if I have 2 times 3 times 4, and I have my parentheses around 2 times 3, I have to do that first. So 2 times 3 is 6, and 6 times 4 is 24. Or I keep the order the same, so I have to have 2, then 3, then 4, but I move the parentheses. Well, now I have to do 3 times 4 first, which is 12, and 12 times 2 is 24. So it's a law of math, a property of math, that it doesn't matter if I move the parentheses. As long as I keep the order of the numbers the same, my answer will be the same. And the last property I want to work with is called the identity property. And again, we have an identity property of addition and an identity property of multiplication. And the key here is what's going to keep the numbers identity. So I think to myself, what can I add to any number that's going to keep that number the same? Well, any number. Let's say x were 2. What can I add to 2 that's going to keep it 2? Well, the only number I can add is 0. So the identity property of addition just says that when you add 0 to any number, that number remains itself or has its identity. And the same applies with multiplication. We think to ourselves, what number times, or a number times something has to equal that number? Well, what's the only number I can multiply any number by that's going to keep its identity? It's got to be 1. So any number times 1 is always going to be that number. Now the reason why we do this is to help us solve problems. We don't just do this to identify the property. We then manipulate equations or numbers to help us solve it more easily. So let's actually see how we would apply this in our homework for today. So one type of problem that you're going to get today, it says evaluate the expression using mental math and then justify your steps. So what you're going to get is you're going to get a problem that looks like this. Now, if I did it in the order that is given, 4 times 19 times negative 25, okay, I don't know in my head what 4 times 19 is. So what I'm going to use is I'm going to use the commutative property of multiplication, and I'm going to change the order of these numbers. So what I'm going to do is I'm going to pull 4 and negative 25 together, because I know a positive times a negative is a negative, and 4 times 25 is 100. Okay, that was far easier to do. Now I want to do times 19. So if I take negative 100 times 19, I know my answer is going to be negative, and it's going to be 1,900. So where it says justify your steps, I want you to be thinking, what is the property I'm using? Here I am using the commutative property of multiplication. So you can see these properties are useful if you're trying to do mental math. We're manipulating the numbers to make it easier to do in our head. Now we can also do it with an addition problem. So when I look at this addition problem, I'm trying to do it mentally. Well, I know that 7 and 3 makes 10. So I think these two need to be done first. So I'm going to use the commutative property of addition, and I'm actually going to do 17 plus 23 first. So I'm going to do 10 plus 20 is 30, and 7 plus 3 is 10, so 30 plus 10 is 40. Much easier for me to do in my head. But I still have to add in that plus 32, so now it's 40 plus 32 is 72. So the justifying my step, well, what did I use? I used the commutative property of addition. So today when you're doing your problems, when they ask you to evaluate using mental math, it means they want you to be using some of the properties, any of them. It can be commutative, it can be associative, it can be identity, and you're going to be moving the numbers around or moving the parentheses in order to be able to physically do it in your head. And where you're showing your work, what you're going to want to do is show how you moved those numbers. I know they're saying use mental math, but you're still showing the work by how you move the numbers, but still you're doing it mentally in your head. Now, a second type of question they're going to ask you to do today is evaluate the expression when A equals 10, B equals negative 4, and C equals negative 2. So what they're going to do is they're going to give you some sort of problem. So it might look something like this. A squared, B, C squared. Well, we know that our first job is we need to substitute in the values of A, B, and C. So I see 10 squared, B is negative 4, and C is negative 2 squared. And remember, there's nothing in between, so I know that all of these are multiplication. Well, again, first I want to solve using order of operations. So I see an exponent there, so I know I have to do 100. I see negative 4, and I see exponents. Now remember, that is going to be a -2 times a -2. And I know a negative times a negative is a positive, so 2 times 2 is 4. Well, I know that 100 times 4 is 400, so I'm going to commute that using the commutative property of multiplication, and I'm going to do these two first. So I'm going to do 100 times 4 is 400. But now I still got to pull in this -4. So I got to now take my 400, multiply it by -4. Well, I know a positive times a negative is a negative. 400 times 4, well, 4 times 4 is 16 with 2 zeros. So this is where I'm pulling it together. I'm still using my property. Now notice it did not say justify your steps, so you don't have to worry about identifying the property that you used. The final type of problem you're going to have for your homework today is they're going to ask you to use a conversion factor to perform the indicated conversion. Don't worry about conversion factors because you intuitively know how to convert these things. So if they're asking me, if I have 27 yards, how many feet is that? Well, I know that for every 1 yard, that equals 3 feet. So if I have 27 yards and I multiply 27 times 3, well, this is where I use my properties again, because I'm going to break 27 down into 20 plus 7, and I'm going to multiply each of those times 3. And this looks a little bit like the distributive property, which you just learned yesterday. So I know I can do 3 times 20 plus 3 times 7. And that's always what I'm doing in mental math. So I'm moving those numbers. I'm using that commutative property again. So 3 times 20 is 60, and 3 times 7 is 21. So 60 plus 21 is 81 feet. So for every 27 yards, if I converted it into feet, that would be the equivalent of 81 feet. So don't get confused by the conversion factor. What I want you to do is just intuitively do what you know is the right thing to do to convert these. Now, you might struggle a bit with the metric system because of most of the United States, we don't really use the metric system. I bet I'm using the metric system in Scotland right now. But if you are going to convert with kilometers, well, if I want to go from kilometers to meters, I think of a stair step. And I have kilo, hecta, deca. These are my base units. So this would be like my meter, my liter, or my gram. Then I have deca, centa, and the 7th step is milli. Well, for every space down, going from top down to bottom, I move my decimal point 1 place. So if I start at 160 kilometers here and I want to go to meters, well, I'm going to move it down 1 place, so I got to move my decimal point over 1 place. That becomes 1,600. I'm going to move it 1 place. That becomes 16,000. I'm going to move it 1 place. That becomes 160,000. So 160 kilometers is the same as 160,000 meters. And if you really think about what I did 10 times 10 is 100 times 10 is 1,000. So I have to multiply 160 kilometers by 1,000 to change it to meters. Now we're going to work a lot more with the metric system, but I just wanted you to kind of preview this. And if you don't get these right, it's okay. Now I've worked all the problems and I want you to look at my work. So if you get stuck, look at what I've done. Hopefully that's going to help you get over the hump. But when I get back next Tuesday, then I'll be happy to go over any of the questions that you have on this. So good luck with your homework. Please stay focused. Make sure you're writing what your steps are, and I'm sure you're going to do a great job. Have a good time. Talk to you tomorrow.